Okay, so I've actually been here 30 years. And so during that time, I've taught this class several times. And also Dr. Utayu taught it. And so we wrote this book. There's actually three irrigation and drainage classes. Um, this one, 456 and 458. And now Dr. Tamimi has turned 458 into a wastewater class that's very popular. So the book has about 10 chapters for each class, and the first 11 chapters cover the material in 455. And there's a link to the entire book here, and on the course homepage, you probably saw it, which is a PDF. And it has all 31 chapters, and it has all the homework answers at the back. So all the homework problems that are going to be assigned, there's answers in the back of the book. And I will also have quiz questions that are not in the book necessarily. So also, each of the chapters has its own PDF document. So you probably want to use that for doing the homework problems in each chapter. And if you want to get the book as a soft cover, hardcover, or my copy soft cover, which just means it's black and white and cheaper, which I like having. I like that. I like having that at home. And I'm not trying to get you to buy the book because it is on PDF. And most of you won't buy the book, but it is nice to have this cheap version here, just in case something goes wrong with the internet or something. Okay, also, you can get to the book through the university library. We have a contract with Springer. If you just type Waller irrigation, it'll take you to the online version of the book. So it's there too. And I'm up to 5.01 million downloads. But maybe I shouldn't qualify that statement. I'll just let you think it's real. No, actually, what happened was during COVID, they made all the Springer books free to download. So people just downloaded millions of copies of the book. But actually, so it stopped at 5 million, and now I'm up to 5.01 million, which I think means 10,000 more downloads. But actually, what that means is, oh, Joe came. Okay. Actually, what that means is there's 30 chapters, so they downloaded the 30 chapters. If they download the whole book, it's one download, but they could download each of the 30 chapters. Then 10,000 downloads. You can see how obsessed I am with this. 10,000 downloads would only be like, I think 300 people. Okay, well, let's hear from Joe. Joe, do you want to, each of us are saying one interesting thing we did this summer.
All right, Dr. Waller, could you repeat that? You cut off for a sec.
Oh, yeah. Each of us are saying one interesting thing that we did this summer.
Oh, okay. This summer I did well, through spring and summer, I did a 6 month long internship with John Deere and Blue River Tech.
All right. Thank you. And you're done with that now?
Yes, well, they wanted me to stay on in Texas permanently, and I told them I had to return back home because of my senior design course that I need to be in person for. So I told them I'd be back in May potentially if they'd still have me.
All right. Sounds good. Okay. Oh, one more person. Hey, Ben. So, Ben, were you saying one interesting thing that we did this summer?
It's Indonesia.
Really? Did you go fishing?
I didn't go fishing. Actually, I didn't even see the beach.
Oh, cool. Sitlali is from Indonesia? Oh, you just went there to go fishing. Okay. Well, Sitlali went to Indonesia also. Okay. Oh, remind me at the end of class, I have to put your grade in for coming. I have it. I closed it. No, no problem. It's understandable today with the hail. Okay. So this class gives you the basic tools to design water resource delivery systems. And as we learned today, rain does not necessarily fall at the right time and place. So water protection systems prevent hazardous effect from storms. And you would learn about that in BE 526 or 426 with Dr. Barreto, where he talks about runoff. And in this class, we'll focus on water resource storage and delivery systems, which collect and store water and then deliver it to places where it is needed, such as cities and farms. And as biosystems and civil and environmental engineers, we design water resources systems that are at the interface between soils, crops, the atmosphere, and then the water resource system itself. And so by understanding the topics in this course, you'll be a more effective, a lot of people go into consulting engineering, from our department, where you do design canals and systems to deliver irrigation water. Okay, so just now we'll go into details about the course. I actually work in the science library on the first floor. I'll see how that goes this semester, but I like working in there. So if you want to find me, I'll probably be there. So if you need help on your homework or whatever, I'll be there. My phone normally blocks all calls. So if you want to reach me by phone, it's probably best to email me first and tell me your number or tell me you're going to call me. Okay. So I don't think I'm going to read through all this because you can just read it, but these are the course descriptions, course objectives, and learning objectives. Okay, so if you turn in homeworks late, I can give 75% credit. And so all the homeworks are due on Friday nights, but I'm going to check your homeworks on the Monday before class at 2 p.m. So I'll generally check it right before class. Probably need an hour and a half to check it. And it doesn't mean I'm going to grade it because you're going to grade yourself. So I have this way to have people grade their own homework. But I'm going to check it and look through it and see how you're doing and give you some comments. So, but anyway, you'll give yourself your grade in the quiz. It's pretty obvious how that works. This time I got lazy and I just have one quiz question, which is do all the homeworks at the end of chapter 1. And then you mark true if you did it. And then you turn the homeworks in to the assignment box, and that's where I'll check your homework. Okay, so I won't check the quiz, I'll check your homework. Okay, all course communications are in D2L, so through U of A email system. I don't ever send anything to Google type email, Gmail. You don't need any extra materials other than the textbook, and there are no extracurricular activities, but we will have some optional activities, such as we had to, because of the storm today, we had to move more crop for the drop to September 5th. So that can replace 1 week of class attendance if you go to more crop for the drop. So, okay. And September 5th is a Tuesday. All right, so there's 11 homework assignments, 1 per chapter, and they're, like I said, they're in the form of D2L quizzes. And there's no excuse for not getting the problems correct because all the answers are in the book. But you should work through them because those will be the types of questions on the exam. There's a project and there are 3 reports and PowerPoints, which I'll describe in a bit. There's also 3 equally weighted exams. And because this is not a computer programming class where you could have a disaster, you know how those go, but it's more like just problems. I'm not going to drop a test. So I normally have quiz questions in the quizzes, and if I do, and I'm pretty sure I will, I have a closed book section at the beginning of the test where you have the exact same quiz questions that were in the quizzes. And then you can turn that in, then you can open up your computer, and then you can do the probably three problems, since we have an hour and 15-minute class. Probably be 3 problems to do. Any questions on the required or the assignments and examinations? Yes?
Yes, I can you repeat that about the closed section of exams, is there some restricted that we think you're in class?
Yes.
Oh,
Yeah, so usually I would have like 10 quiz questions, multiple choice. And I will have the exact same quiz questions randomly selected on the test,
oh,
closed book.
Yeah.
Okay, here's the syllabus, or here's the grading scale. So each of the midterms is 20%, 3 midterms. Homeworks and quizzes 14%, the group project is 20%, and the final exam is 20%, and class participation is 6%. Here's the schedule. And so it's pretty obvious what's going on here, just going through the chapters. But anytime there's a star on a Wednesday, that means that homework, that chapter is due on the Friday night at midnight. But I never check it before. I don't close the quizzes. I just have due dates. And I never check the grades until Tuesday or until Monday at 2 o'clock in this class. So you could turn it in late and you wouldn't get docked for it. But once I check it on the Monday at 2 to see if you've done it, then that's fixed. There's you can turn it in late after that, but you don't get full credit. Okay, then we have 3 sets of presentations, and since we have 20 or 22 people in this class, we need 2 class periods to do it. And each presentation is going to be 3 to 5 minutes. And so, and I would like them to be live this semester. And so that'll take a block of basically a week. And then the first midterm is on October 4th. It'll be chapters 1 to 4. And then we'll have our second presentation, second midterm, and then third presentations and final exam. Final exam is comprehensive, but it'll be weighted more on chapters 10 and 11. Okay, any questions? Okay, so I don't really work in Excel that much anymore. I work in Python, but when I developed this course, I made Excel spreadsheets. So there's Excel spreadsheets corresponding with many of the chapters. You can do the problems in RStudio or Python if you want to. And I have a Posit Cloud instructor subscription for RStudio. It's a lot easier to use RStudio in the cloud under this format than it is like to have it on your computer. And I have an expert RStudio programmer who works with us, who's available to help you on Tuesdays in the library if you want to work in R. And we'll talk more about that related to the projects. Okay, so let's talk about group projects. You'll form groups of 4 students. Since it's 20% of the grade and 135 hours is expected for a class, it'll be expected you'll spend 27 hours. And there's 3 project options for the groups. You can do topics and data related to our irrigation research, such as sensors, soils, and evapotranspiration. You can develop an irrigation app and website design. So that would probably be in RStudio, since that's the environment we use, but maybe you do websites in other languages like Python, Flask or something. And actually the RStudio will run Python too. Or you could do a farm irrigation infrastructure design. So I didn't want to have the project be to design irrigation systems because we really don't go through that in this class, but we do talk about infrastructure like canals, you know, the site survey, the soils, the salinity and all that. So, and actually, if everybody wants to work on this third option, that's fine. And I wanted to go through option 3 first, just to emphasize that I really, I'm not encouraging you to work on my research. You know, if you want to, you can, but this is an option that everybody can do. So what the group will do is they'll design an irrigation infrastructure, canals, pipes, and pumps, which requires that you know the characteristics of the crop and the soils and everything also, for a section, which is 640 acres. And what we'll do is we'll divide up the tasks, and I'll show you how we'll divide up the tasks. And the steps are typical steps in an irrigation development project. You know, first you do the site survey, then you do the economics, or maybe that's last, but anyway, you do economic analysis, you evaluate the soils, look at the irrigation water quality, calculate how much evapotranspiration there is, and then you start laying out the pipes, canals, and things like that. So it's just a very typical project for an agricultural engineer or civil engineer. And what I did is I set it up in 3 steps so it'll go along with the book. So during phase 1, which would be your first presentation, each of the people in your group will select one of these 4 tasks. So one person will do the selection of a section and site review, like Google Earth image, find the water source, find the water or water sources. Maybe it's a combination of groundwater and surface water, which is common in Arizona agriculture. And actually, it doesn't have to be 640 acres. It could be less than that, but that's, you know, that's a typical size farm in Arizona, actually. And you can either select an existing farm to modify or, you know, just pretend it's not there, I guess. Or you can break out new ground, which requires, you know, some soils development with salt tolerant crops at the beginning and things like that. So anyway, I'll work with your group to think through some of those things. The second person will do economics, and what you'll do is a 20-year economic evaluation of the planned crops, the planned inflation rate, the inputs, and so on. The third person will do the soil characterization, and we use, or you can use NRCS soil maps. So the whole country is, you know, not extremely well characterized, but the soils in the whole country are characterized. You know, they have like lines where different soil types are and so on. So the third person will do that. And the fourth person will do I said salinity assessment, but maybe we should say water quality assessment. And they'll look at the soil and water salinity, specify the salt tolerance of the crops, and recommend a leaching fraction for each crop, which is how much extra water you have to put on to leach the water through the soil. So that'll be the first phase of your project. And then you'll write a 750-page report on that. And I'll talk about that in a minute. Okay, so that would be phase 1 of this project. Phase 2 of this project, which would be the middle 4 weeks of the semester, or 5 weeks, would be divided between reference evapotranspiration so the person who does that will have to select the nearest weather station, download the data, and I have programs to do that. And they'll have to characterize the average reference ET for the year. That's based on the environment, not on the crop. And then the next person will do crop evapotranspiration. So what you do with that is you take the crop coefficient curves and you overlay that onto the reference evapotranspiration, and you calculate how much water the crops will need. So that's very important when you design your canals, pipe systems and so on. And then, the next person will do irrigation system selection. So based on soil type, based on crop type, there's certain recommended irrigation systems. Like if you have a sandy soil, you're not gonna pick a flood system. Or if you have, let's say lettuce, you're gonna grow lettuce, you're also not gonna pick a flood system. Or even a sprinkler system, or actually you might pick a flood system, but not a sprinkler system. Because it's against the rules to water, vegetables with sprinklers because, well, I don't know, did you hear about the 3 people that died due to listeria in the milkshake machine? I just thought of that because I read about it today. But there's contaminants in irrigation water. And so there are certain rules to prevent people from getting sick. We have rules in our society for wastewater, for food preparation workers. Well, there's also rules for irrigation to prevent diseases from being propagated. And actually, irrigation has been the source of disease propagation in the past, very bad outbreaks of disease. So you have to be careful. So one person will select the irrigation systems for the farm. They won't design them, but they'll select them, based on efficiency, cost, things like that. It's a lot of considerations. And then the next person will do the mainline design. So there might be 2 levels of water conveyance systems on the farm. There might be larger canals, and then there might be pipe systems. So I don't know how that'll work for each farm, but somehow you'll have to come up with some idea of where you want your pipes and where you want your canals. Okay, and then the third phase of this project will be pump selection and design. And these are all corresponding with the chapter numbers too. Groundwater and surface water supply. So where are you going to get your water? And I don't think we have hardly any graduate students taking this course, right? I was going to have the graduate students do an assessment of the risk of water shortage due to global climate change, with Lake Mead water levels falling, or actually this year they're rising. But, this last year, the farmers in central Arizona were completely cut off from Colorado River water. So they basically got half as much water as they normally get. So, that's a major problem. And so when you're considering designing a farm, you have to consider the security of your water. And then number 11 is canals and ditches. So that would be the canal layout on the farm. And then one person will do the final report collation, making sure everything's in the right font and so on. And I'm going to, let's see. Yeah, I'm going to have rubrics. I didn't have time to develop all the rubrics, but I need to have the rubrics done at least for phase 1 by Monday. So you'll know what is expected. Okay, and then we have 3 projects related to our research. So one is create an API for OpenET. An API is a application programming interface, something like that, where you download the data from a site. And we have started doing that. We've downloaded data from one site successfully. And so it's not that hard to do, but anyway, OpenET is this new system that's throughout the Western United States that uses satellites to measure evapotranspiration from farms. And so what we're doing with that research project is we're comparing our water use, which is from a center pivot, with OpenET estimates of water use. And we're also using field sensors, our model. And so what this group could do if they're interested is work on that. and possibly incorporate it into our studio in our web app. So now the program for the WINS model is in Python, but then the web app is in our studio. So we made a lot of progress on it this summer. And like I said, actually it's Reed Leffler. Some of you might know her. She's actually in biomedical engineering. She used to be in biosystems. Trying to get her to see the light that irrigation is much more important than biomedical. But anyway, she's very good. And so we just keep hiring her to come back, even though she's in biomedical. Okay. The second project we're working on is we're irrigating cotton with 3 different irrigation systems. Gravity drip, which is a really cool new system that doesn't require pressurizing the water. So that's great for not causing global warming, because pressurizing water takes energy. And we're using conventional drip, which is you know, the buried subsurface drip that actually requires about 30 or 40 psi pressure when it's all said and done, because of the sand filter and all that. And surface irrigation. So we're comparing the growth. We have like 30 sensors in the field, or maybe 40. We measure the soil moisture with neutron probe. And actually, the student that works on this is going to help this group. She'll work with you. And we have all the data in our studio. And so there's lots of things to do with that, which are interesting, like evaluating sensors, comparing them, and so on. And also we do drone flights over the field. So maybe processing the drone images and so on, or evaluating them. Okay, and option 3, 1-3, is we have data from Waiuli experiments for the last 6 years. And Waiuli is a rubber crop that's becoming popularized in Arizona. And most of those experiments just use our neutron probe sensor. It's a manual sensor that you drop into the ground and measure the water content every week. But we also have one experiment going on right now with an AquaSpy automatic sensor. And anyway, the group that works on that could calibrate the WINS model to the different sensors and calibrate the sensors to each other, possibly use AquaCrop, which I don't think I mentioned. That's a crop growth model. Okay, so those would be the 3 experiment options. And then the last option is we have a WINS website online, but we have other things we want to develop. Like we want to make an irrigation app where the person puts into their phone which field they just irrigated and how much and so on, that kind of thing. So we do have Google Earth Engine working in the app, but we haven't done much with it. You know, we can just outline like experiment treatments, but we do have it going. And that's why I said the cloud, RStudio, is a lot easier than just doing it on your own computer, because it has all the tools like JavaScript, everything you need, all the libraries. So it's much easier. It's not that bad to use in the cloud. And we can work with you in the cloud because we can see what you're doing and so on, you know, because you have sub accounts under our account. Okay, but there's other things you can do with that, developing a website. And I feel okay about this project because, you know, it is design. You're designing a website. It's just not an irrigation system. So, but I think a lot of you are going to want to design the irrigation system or the infrastructure. You know, those of you thinking of going into consulting, that's right down the line of what you'll be doing. I mean, some of you might be designing tanks like Carolyn, but ultimately you'll probably move on past tanks, right? Or not? Well, once you get really good at tanks, I guess they leave you there. Okay, what kind of tanks are they? What kind of tanks? Oh, brine for like desalination? Oh, that's interesting. Are they doing desalination in Tucson?
It's like in between two slides.
Oh, cool. Okay, now, oh, Chat GPT. See, I may even spelled it wrong. I should have used Chat GPT to make this PowerPoint. But anyway, my daughter does graphics design. And so she had this job and she used Chat GPT, and it's like the only thing the guy liked was the Chat GPT part. I think Chat GPT is amazing, amazing tool. So if you want to use Chat GPT to write your 750-page report, that's fine. I just think it's good to use. I haven't used it myself, except to figure out a programming problem. And actually, I was sitting with somebody who used it to figure out the programming problem. But well, anyway, my story on that is we spent 2 hours trying to figure out a programming problem. And then we typed it into ChatGPT and figured it out instantly. So what I'd like you to do is, if you do use ChatGPT, I'd like you to include your input to ChatGPT as well as the ChatGPT. Okay. Yeah, I've never used ChatGPT, and I've never used ChatGPT in a class, but so I really don't know how to control this, but let's just see how it works. If you want to use, I think it's good for you to have some experience using ChatGPT. Okay. And so, like I said, the details on the required elements, which would be the rubric, will become by next Monday. And the report is due the night before the first presentation day. So there's 2 presentation days. The night before, everybody has to turn in the report. Then the PowerPoint presentation is 3 to 5 minutes, 3 slides with 2 graphics minimum. And that's due the night of the second presentation day. So after all the presentations. Okay. And I imagine everybody wants the second presentation day usually. So if that's a problem, we'll just switch back and forth between who gets first and second presentation day. Okay, and then all the policies for University of Arizona, we can now just put this here. So all the academic honesty, toleration, whatever policies, they're at that site, just as if it's in the syllabus.